This is going to be about the Altapure system. Altapure is a new technology for high-level disinfection. It's not a high hydrogen peroxide system. It's not a fogger. It's cold sterilant. It's not UV light. So it's a completely new technology. And I'm going to go over I'm just going to start this. And what you're looking at here is the system in a small cube that we use at shows. And this is kind of like a small demonstration of how it would behave if the video was running a little slow. Yeah. What it does is it fills a complete volume with aerosol. It's based on the size of the room. It dwells. It kills all the bugs and contamination, and then it's reprocessed and the room is ready to re-enter. So in this particular cube, wow, it's a 4.5-minute video, and it's obviously we can treat an entire space, an entire patient treatment area, the average single use in about 30 minutes. And you're going to get a greater than 6 log reduction. You're going to get a total kill. You don't have shadowing. You don't have to worry about distance. It's a fire and forget solution. The EVS operators will set the machine in place. They operate it from a tablet outside the room. It's similar in operation to the BioQuil, except it gets a kill in about a quarter of the time. The average double patient room area, we can affect that in about 35 to 45 minutes. And that's from the time you enter the room, clean the room, set up the equipment, run the process, and get back out. So, and what you're seeing here is what it would look like in the room. And it stays full. I don't know, the videos, looks like it's running 2 of them at one time. But if you look at our video over in the presentation hall, you can get a better look at it. But it'll run, it'll fog, and then it reprocesses. And there it goes. Now, because of the video, it's not really displaying the way we wanted it to. But the idea is that in real time, this cube, this is a 3-meter cube. It would completely disinfect this device, or this particular area, in about 15 minutes. So the average patient area is double that size. Like I said, this is for display purposes. But we don't accelerate the video. It's the actual time it takes to fill and recover. It's safe on all of the furnishings in the room. And the aerosol is generated ultrasonically, and this is what makes it new. There's no other product like this right now. Now what you're seeing right here is that the space is beginning to, it's going through its drying process. And like I said, there's no acceleration on this. This is just the way this is running. And it'll completely dry the space. There's no wipe down necessary. There's no post-process cleaning regimen that needs to be done. Safe on the equipment, safe on the furnishings. The aerosol is 98% water, 2% chemistry. Carl's going to talk about that. And with that, introduce you to Mr. Riccardi, one of the original founders.
All right, assume this is working. As you can see, the end process is a complete dry room, and it's a total kill. We don't have the issues of many of the modalities that are used in the U.S. are starting to migrate throughout the world, and the Altapure system is somewhat similar to a system that was invented in the UK, BioQuil, which is a 35% hydrogen-based system, which has been around for quite a long time. The advantage of a system like ours, or like the BioQuil system, is that you get a total kill, a 100% kill in all surfaces of the room, the ceilings, the floor, the walls, under. You can open drawers, you can open the doors. It goes under the toilet seat. It goes everywhere. It does not have the limitations of UV light. And I'm going to get, especially, I just listened to the last presentation. I'm going to make some comments on that. But what I'd like to do today is give you an overview, kind of an evidence-based, literature-based explanation of this particular modality. First of all, I heard the talk this morning. The first speaker on sepsis was talking about the evolution of antibiotics, and it's kind of ironic that it was founded right here in England in 1928. Penicillin was developed just prior to the war. It was used during the war and commercialized about 1945. It was then patented in 1948, again right here in England. Within 4 years of the commercialization and use of penicillin, they had already discovered resistant organisms. Colistin was a drug that I believe was like 1947, and colistin failed 9 months ago in China, and it failed 6 months ago in the United States. Colistin was the drug of last resort in the United States, or in the world. So when colistin failed, next slide, Paul. Just stand back there. Yeah. When colistin failed, the world entered something that was unique, and that we have now entered the end of the antibiotic era. So in 67 years of medical science, that's what it was. It lasted 67 years. So kicking and screaming, all of you who are in infection control and those of us who offer products in infection control are faced with an entirely new paradigm. And recently there was a woman in California who got an infection, a hospital-acquired infection. She got 23 different antibiotics and she died. And so those of you who grew up in the business where penicillin and streptomycin and all of the drugs that were available in your arsenal to treat infection are going to be faced with a new situation, and that is the cleanliness becomes more and more important because you have less tools, less arrows in your quiver that will make a difference. So the Altapure system, the chemistry and the physics of it is very unique. It's an ultrasonic creation of a very, very small droplet. It is submicron, 0.69 microns. And there is a physical relationship between droplet size and gravity. It's just common sense. The smaller the droplet, the less it's affected by gravity. The less it's affected by gravity, the further it goes. And it has a long hang time. In this video you saw, it looked like smoke. And the reason is because there's 5 to 7 trillion small droplets in a cubic foot. And so what happens is it's the physics of small droplets. It's attracted to the surface. So that pathogen is being bombarded with literally billions and trillions of small drops. And PAA, proxyacetic acid, in our machine, it's 98.4% water and 1.6% ingredients. And the ingredients is the substance our grandmothers used, vinegar, and hydrogen peroxide. Our hydrogen peroxide is 0.88%. So it's less than 1% hydrogen peroxide and a very, very small amount of vinegar. It creates a chemistry called parasitic acid. And parasitic acid is in my view, as a science guy, it's a beautiful chemistry in that it is not toxic. It is a violent killer of pathogens and ends green. It breaks down into water vapor and a little bit of vinegar smell, which again breaks down into harmless products. So here you have a chemistry, where's that apple? Oh, it's a chemistry that is, and it's a paradox because it's a chemistry that will kill Ebola, it'll kill anthrax, it'll kill C. diff, it'll kill the emerging C. aureus, staph, et cetera, in a very short period of time. And then it ends green. And if you had a salad or an apple in the same room, you could eat that without any fear at all. Parasitic acid is approved in the United States by the USDA, which controls food prep, for direct application to food surfaces and food without rinsing. So when you look at the chemistry, you shake your head and you go, how could this be a chemistry that can kill all these pathogens very quickly and then end green with no residue, et cetera, et cetera? And that's the beauty of the Altapure system. So you don't have to worry about toxicity and other chemicals. You don't have to worry about silver residue. It just disappears. Our D value is 2.3 to 2.6 minutes. And for those of you who work in the area of sterilization, all of your sterilizing equipment has a D value. And the D value is standard across the world. So our D value is 2.3 to 2.6 minutes, which is very fast. One thing you will never see with the UV light products is the D value. And if they do, it's going to be on a selected surface within 3 meters or 4 feet of the light source. Our D value applies to the entire room. So when you do a hospital room or a patient room or an operating room with the Altapure system, these small droplets go everywhere. You can open the doors, you can open the drawers, you can bring in other equipment. There is no shadowing. And so you can be assured that at the end of the Altapure cycle, you will have greater than a 6-log kill. Not a reduction, but a kill. So just as a side note, Paul, next slide. The EPA, the Environmental Protection Agency in the United States, has defined disinfectant as a greater than 6-log reduction in less than 10 minutes. UV light does not meet that definition. So all of the chemistries that you guys use in your businesses, all the wipes, all the chemistries that are used to wipe off surfaces will have to be called a disinfectant. They have to demonstrate a greater than 6-log kill of selected organisms, not the easy ones, the tough ones, the G. stereothermophilus and the B. atrophius, in under 10 minutes. And if you can't do that, you can't claim to be a disinfectant. So in the United States, the word disinfectant has become a noun and a verb when you say we're disinfecting. And in reality, many of the so-called products that claim to be disinfecting aren't really classified as disinfectants. The key for the Altapure system is that it gives you 100% kill in the entire room. Not a log reduction, not just selected surfaces, but everywhere. And why is that important? Because if you do not kill all of these organisms and more, you leave behind a bioburden. And that bioburden, the literature shows, will migrate through a hospital. And if you have CRE and VRE, and you have C. aureus, and this is back in the days 6 months ago when you had antibiotics, you had a 40 to 50% mortality rate. 40 to 50%. Most of us wouldn't walk in a room if we had a 40 to 50% chance of not coming out. So with the new era, this end of the antibiotic era, it becomes extremely important not to leave behind a viable bioburden. The chemistry, it's not corrosive. In other words, you can leave your computers in. We have our customers leave all of the patient monitoring equipment in the room. You can bring your cell phones, you can bring your shoes, you can bring the computers. It's all there. All the patient monitoring leads are clean. So that's an added advantage. The other advantage with the Altapure system is the patient privacy curtains. Just open them up. So unless the curtain is soiled with organic soiling, you will get a total clean or total kill on your privacy curtains. It's a cost reduction. The other thing is offensive odors in hospitals. The system actually oxidizes the odor radical and it destroys it. So when you're all through, you're going to have a room that smells clean. It will be clean. We say we're the fastest kill in the world, and that's because we have evaluated all of the other modalities, and in the literature itself supports what we say. So if you have a hospital, a busy hospital, and you're turning rooms over, and it's important to have a room with your EVS staff and a total clean, you can be in and out of that room in 50-some minutes. And you can rely on the fact that room is virtually sterile. Next slide, Paul. The key, in my view, as we've entered this new era, is elimination, not reduction. Reduction leaves a bioburden, it leaves a biofilm, and once you have a biofilm developing, it's very, very difficult to get a clean room. We don't have any shadowing. We don't rely on allegedly reflection of light. We're faster than the UV light products. And if you want to compare, if you're looking for a modality and you say, we want to have a clean room. We want to rely on the fact that our staff and our patients will not be exposed, which makes really common sense in light of where we are. You want to pick a modality that says when we go in and spend the money to buy a product and we take our time to use that product, we want to be sure that all the surfaces have been cleaned, not just selected high-touch surfaces. Again, the monitoring screens on computers, some of the UV light products actually destroys the screens. They get cloudy. Some of the patient monitoring equipment, we've seen where the patients, where those products are being destroyed. And the Altapure system meets the EPA definition of a disinfectant, and that we get a greater than 6 log kill in under 10 minutes. And so you can have us give you answers that are based on the literature. And in fact, I will give you the site of the literature. So my previous speaker was speaking on UV light, and he talked about the literature. Well, what I encourage people to do is to get that study and read it and look at the claims that are made and look what the evidence is. And there's been a number of pivotal papers in the last 2 years. You got to remember, this no-touch technology across the world is less than 6 years old. And that started historically because patients were getting hospital-acquired infections, and EVS people and people in infectious disease asked the questions, well, how can that happen if we're wiping off all the surfaces? So the scholastic folks, academics, started looking at the process, and they went, oh my God, when you're all through with the hand wipe system, 50% or more of the surfaces are still dirty. So there was a period where a whole bunch of papers were published on that issue. The next pivotal paper in this long line of literature published in the last 5 years was a woman named Megan Shaughnessy, a doctor at Michigan University, and what she found that if a patient is put in a room where the prior patient had a serious infection, that the statistical probability of the next patient getting that was up in the 70s. So what happened then? Then there was this great big flurry of people publishing and looking, and then they all agreed with Dr. Shaughnessy. Then along came the no-touch technologies, because if the people doing it, and people also have the same problem, they have a bad day or something goes on or they miss it, you cannot rely on handheld stuff. So then they started looking at the no-touch technologies, and BioQuil right here in this country was basically the first one, and it worked. And I tell people that if I were to go to a hospital tomorrow for a surgery and I couldn't have Altapure, I'd have Bioquell. Because although it takes 3 to 4 times longer, what we do in 50 minutes takes them 2, 3, 4 hours. But the result is good. So that's my criteria for myself personally, is you've got to pick a technology that will deliver that total kill. And then as we look at the literature, and again, I've got bibliographies which I can give you, there's then a whole line of other papers looking at these various options, the UV light option, the spray options, the hydrogen peroxide and silver, and on and on and on. And each of those has been evaluated. And so prior to making decisions, what I encourage people to do is look at those five pivotal papers. And for those who think UV light is an answer, what you have to look at are the results. And what do the results say? The results say 2 to 3, 4 log reduction. That's it. And that's not even an entire room. So what you have to be concerned about is is a log reduction okay? Are you going to accept the risk, or do you want to pick a modality that gives you an elimination of bioburden? Okay, Paul.
Yeah, thanks, Carl. He's absolutely right, and so we've developed this process that in the UK, because they have the Bioquell and they're used to the total kill and the results, we really are excited to introduce this here in the UK. But it's similar in scope. We have the deploy, the dwell, dehumidification, and deodorizer, which is filtration. The unit is actually designed for the terminal clean process or the deep clean process. Typically, you have about 10% of your staffed beds are discharged as precaution or deep clean needing. So one machine can keep up with about 150 staffed beds handily with the amount of turnover that you have with standard FM services. If you're 300 beds, 500 beds, then you would want to add these units appropriately to be able to maintain your program. So the unit has an aerosol output, which is the small part, and then it has the dehumidification and the deodorizer. So really, it's built this way. It's designed for speed. It's designed for consistency and reliability.